Let me say something that might sound wrong first. Scaling is not about traffic, it's not about users, it's not about page views, not we are going viral. Because here's the truth, if traffic alone could scale a system, every app that went viral would survive. But the truth is, most don't. They crash, they slow down, they burn out their teams, or they quietly disappear. So today, we're actually talking about what scaling actually is and why traffic is usually the last problem, not the first. Welcome to Inside the Stack. When most people hear the word scaling, they picture one thing: more users, more traffic, more requests per second. And that makes sense because those are the things that we can see. We can see charts going up, we can see dashboards lighting up, numbers climbing. But here's the misconception: traffic doesn't break systems, weak assumptions do. The truth is, you can have very low traffic, a handful of users, and very small data, and still you bring your system to its knees. How, you might ask? It's by making assumptions that only work in perfect conditions. You are assuming the request will always come one at a time. You are assuming that the database will always respond quickly. You are assuming that failures are rare. You are assuming that retries won't matter. Well, the truth is, those assumptions feel safe when things are small, but there are already cracks in the foundation. Scaling problems don't suddenly appear at scale. They show up early. They just hide better. They hide behind low usage. They hide behind fast responses. They hide behind it works on my machine. The typical developer answer to, hey, this is not working. It works on my machine. And then one day, when traffic finally does arrive, those hidden problems start showing themselves all at once. So that's why scaling isn't about traffic. It is about whether your system was designed to handle reality and not perfection. So, if scaling is not about traffic, what is it actually about? Well, scaling is really about one question: can your system handle growth without collapsing? And when we say growth, we don't just mean more users, we mean growth in data, we mean growth in features, growth in complexity, growth in teams, growth in integrations, growth in expectations. All of this happen long before traffic explodes. Your database grows, your tables get wider, your queries get slower, your product grows, new features pile on top of old ones, edge cases multiply. When your team grows, more people touch the code, more assumptions get made. At this point, more things can go wrong. You start adding integrations, you start adding third-party integrations, payment providers, email services, analytics, third-party APIs. Now, each one adds more risk. Each one adds failure modes, and expectations definitely grow too. Users expect faster responses. A 1 minute load is not expected to happen in less than 10 seconds. They expect fewer errors. They expect better reliability. The bar keeps rising, even if traffic doesn't. That is why traffic is just one dimension of scaling. And honestly, in my opinion, it's the easiest one. If traffic increases, you can add more servers, you can scale horizontally, you can throw hardware at the problem. Yep, you throw enough money to buy the whole US East 1 region on AWS. But bad design, you can't scale that away. Tightly coupled systems don't get better with traffic. Slow queries don't magically speed up. Missing indexes don't fix themselves. Fragile assumptions don't become strong. In fact, I can tell you that more traffic often makes bad design fail faster. It exposes the cracks, it amplifies the weaknesses, which is why most companies only see the need to scale when they have traffic, when they have like high volume of traffic. So real scaling is not about preparing for success, it's about preparing for change. What are those changes? Change in data, change in behavior, change in the team, change in the system itself. If your system can grow, if your system can evolve, if your system can absorb pressure without falling apart, now that's scaling. Okay. So what really breaks the system? If traffic isn't what usually breaks the system, then what does actually? Let's talk about the real culprits. The things that quietly kill systems long before they go viral. The first one surprises a lot of people. It's not user growth, it's data growth. 10 users, just 10 users can generate millions of rows. At this point, you have heavy joins, you have painfully slow queries, especially when indexes are missing, when queries are unbounded, and assumptions were made early. Assumptions like, hey, this table won't get that big. Hey, this query runs fast enough. It's fast enough for us right now. Hey, we'll fix this later, not now. Later always comes, definitely. Most systems don't die from traffic. They die from the bad data access patterns. Because once your data layer struggles, everything, I mean, virtually everything above it suffers. Now, this other is coupling when everything depends on everything. System A depends on system B. So once one service goes down, others they follow straight. Now it's not because the others fail, but because they were too tightly connected. Now imagine an app where placing an order does everything all at once. The other service checks inventory, it charges the customer, it sends a receipt, it updates analytics, and it notifies the warehouse all in one flow. Now, one day the email service is down. Nothing about inventory is broken, mind you. Payments are fine, orders could still be placed. But because the order process depends on email succeeding, the entire order fails. Now, that's tight coupling. One failure blocks everything. Scaling hates tight coupling because as system grows, so does the blast radius. Failures spread faster, impact becomes wider. Debugging takes longer. Now, what used to be a small issue becomes a full outage, and the entire engineering team, what was supposed to be like a backend change, just if it were not tightly coupled, it could be a backend change. But because there's tight coupling at this point, everyone is sent scrambling to put everything together. Loose coupling contains failure. Tight coupling amplifies it. Now, the third one is subtle but deadly. States in the wrong place. Now, what do I mean by this? It means when sessions live in memory, when logic depends on local state, when an instance knows too much, everything works until you try to scale horizontally. Because at that point, you can't safely spin up another instance. Requests behave differently. Users get logged out. Data becomes inconsistent. What the user says before, they don't see it again. Now, if you can't add another instance without fear, you are not scalable, regardless of traffic, whether it's small or whether it's large traffic. You are not scalable. And finally, the one nobody wants to talk about, human scaling. Truth is, if only one person understands the system, if deploys are scary, if changes take days or weeks, you are already at your scale limit. Even with 10 users, even with 100 users, you are already at your scale limit. And why is that? Because systems don't just run on code, they run on people. And if your team can't move safely, the system can't grow. That is just the truth. Now, the big takeaway, I want you to notice something important here. None of these problems require massive traffic. They show up early. They just hide better when things are small. Traffic doesn't create these problems, it reveals them. Now, I mentioned earlier that traffic is the easy part. And I said that not because traffic is trivial, I said that because it's visible. When traffic increases, you can see it. CPU spikes, memory usage climbs, response time goes up, from dashboard light up, alerts fire. You see a lot of Sentry alerts, you see a lot of Slack alerts, you see everything. You know exactly what is happening. And the truth is, we have tools for this. We have tools for this. We have load balancers, we have auto scaling, we have caching, we have CDNs, we have one, just scaling, just adding in more servers. Because if traffic goes up, what you just do is you add capacity. It's mechanical load balancing. Tech has made it so easy that these things could be fully automated. What we don't have great tools for are the invisible problems. When there is unclear boundaries, when there is leaky abstractions, when there is hidden dependencies, when they just ship it shortcuts. These are things that don't show up on a dashboard. They show up as confusion. They show up as fragility. They show up as slow change, fear of deployment. Traffic doesn't create these problems. It exposes them. It turns small cracks into visible failures. That's why some teams often say everything was fine until we got more users. But the truth was, it wasn't fine. It was just quiet. Traffic is like turning up the volume. It doesn't change the song, it just makes you hear it clearly. So, if your system struggles under traffic, the work usually isn't in adding more servers. Yes, it might fix it in the short term, but it isn't in adding more servers. It's in fixing the design decisions that traffic made impossible to ignore. So, with what I've said so far, let's rewrite the definition of scaling. Because scaling is not just about handling more traffic. Scaling is about predictability. A scalable system is one where you can predict how it will behave change. It's not hope. You don't hope. You don't guess. You predict. You ask yourself questions like, hey, can you add a new feature without fear? Not that we just break everything. Not let's deploy at midnight just in case we deploy at midnight so users don't see when things break and we can quickly get everything back up. But you can say this with confidence. Like, can you onboard a new developer easily? Can they understand the system without sitting next to the original author of the code? Can they make a change without being afraid of the invisible side effects? Can your system handle more data without rewriting everything? Can there be more rules? Can there be more history? Can there be more records? Does it slow down gracefully or does it fall off a cliff? Can your system survive partial failures? Like if one service is down, does everything stop? Or does the rest of the system keep working? Maybe with reduced functionality. If the answer to these questions is yes, you're scaling. Congratulations. Even if you don't have massive traffic, even if you only have a few users, even if the charts aren't going up yet, you are scaling. Why? Because real scale is not about pressure, it's about resilience. It's about knowing what will happen before it happens. Traffic doesn't give you predictability. Good design does. Clear boundaries, thoughtful data models, loose couplings, and systems built to change. So, if you can predict how your system behaves as it grows, you're already scaling. Traffic is just a future test. It is not the definition. Let's make this real because none of this is theoretical. They are real life applications to all this. These are problems that show up in real systems that show up every single day. You can have an app with just 1,000 users, with just 100 users, but with a massive data pipeline behind it. You could have logs, you could have events, have analytics, have audit trails. Suddenly you are processing millions of records, running every queries, and generating reports that take minutes to load. Now that system didn't fail because of traffic. It failed because data growth wasn't planned for. Or take internal tools, apps with very few users, just in-house apps, sometimes with just one team. But the moment someone asks for reporting, everything slows down. Pages time out, the database starts struggling. At this point, it is not because many people are using it, but because the reporting workloads they were bolted on without thinking about access patterns. They were bolted on without thinking about usage. They were bolted on without thinking about the patterns themselves. We have reads that are competing with writes. We have heavy joins running in production. That is not a traffic problem. That is an architecture problem. And then there is this one, the most painful of all. Simple features. A small change that should take an hour, but somehow requires touching 12 files. Oh, you have the models, you have the views, you have the services, you have the helpers, you have the configs. Every change feels risky. Every deploy feels tense. That's not skill. That's tight coupling and unclear boundaries. Notice the pattern here. None of these systems failed because they had too many users. They failed because growth exposed design decisions that didn't age well. Now, before we wrap up this episode, let's talk about a few traps that almost everyone falls into. They sound reasonable, they sound practical, and they quietly create scaling problems. The first one is we'll optimize it later, which usually means we are making assumptions we haven't tested. But later doesn't magically make codes easier to change. It usually makes it harder. And then there's this one. It's just an MVP. And in all fairness, you shouldn't over engineer. That's true. You shouldn't over engineer. But it being an MVP doesn't mean you should be careless. If your MVP add codes assumptions, couples everything together, and ignores failure paths, those decisions don't disappear. They calcify, they harden. Here's another classic. We don't have many users yet. That statement is about traffic, not complexity. You can have few users and still build something fragile. And then when growth does come, those early shortcuts show up immediately. And finally, we'll fix this when we scale. This one is dangerous because you don't scale into good architecture. You scale from it. I repeat, you don't scale into good architecture, you scale from it. Good architecture isn't about predicting the future. It's about avoiding the decisions that make the future harder. It's about small, thoughtful choices early on that make scaling possible later. So at this point, a fair question is, okay, if scaling isn't about traffic and shortcuts are dangerous, how do we avoid over-engineering? Yes, because nobody wants a system that's complicated for no reason. The answer to that is not to predict the future. It's to design for change. You start by drawing clear boundaries, not microservices, boundaries, not fancy architecture, just clear responsibility. You know, this part owns data, this part handles the business logic, this other part deals with presentation. Boundaries reduce blast radius. They make changes safer. Next, make the slow parts obvious. If something is expensive, say so in the code. Where we have large queries, where we have external APIs, where we have heavy processing. Don't hide them. Visible cost is manageable cost. Design for failure early. Assume things will slow. Assume things will break. Assume dependencies will be unavailable. That doesn't mean building complex fallback system. It means asking, what happens if this fails? Keep states in the right place. Stateless services scale naturally. Stateful shortcuts, they come back to hurt you. And finally, optimize when reality demands it, not when fear suggests it. You measure first, you understand the bottleneck, then you fix the thing that's actually slow. Okay, So let's end this episode with one final mental method. Because if you remember this, you'll never think about scaling the same way again. Traffic is pressure, scaling is structure. They are not the same thing. Pressure doesn't create cracks, it reveals them. The cracks were already there. Traffic is just load. It is more requests, it is more data moving through the system. And when pressure increases, everything gets louder. Slow queries become obvious, tight coupling turns into outages. Hidden assumptions, they stop hiding. But here's the key insight. If your system is clean, if responsibilities are clear, if data access is intentional and failure is expected, traffic is just maths. You add capacity, you scale horizontally, you adjust numbers. But if your system is messy, no amount of traffic planning will save it. Why? Because pressure doesn't fix structure. It only tests. And that's why scaling work happens early. In how you model your data, in how you draw boundaries, in how your team works, in how you change flows through the system. So don't fear traffic, fear unclear structure, because traffic will always come later. Structure is what decides whether you survive it. Remember once more, traffic is pressure, scaling is structure. If your structure is sound, traffic is just maths. So let's bring this home. Scaling is not about traffic, it's not about going viral, it's not about charts going up and to the right and to the left. Scaling is about whether your system can grow without collapsing under its own complexity. It's about predictability. Can you add features without fear? Can your team move fast without thinking about breaking things? Can your system handle more data, more integrations, and more expectations without needing a full rewrite? Traffic doesn't create these problems, it exposes them. And that's why scaling isn't something you do later. You don't scale into good architecture, you scale from it. So the next time someone says, we worry about scaling when we get users, ask them one simple question. Scaling what? Because if the foundation is shaky, more users won't save it. They'll just expose it later. If this episode helped you to rethink what scaling actually means, share it with a teammate, a founder, or an engineer who is worried about scaling too early. Subscribe to Inside the Stack for more conversations like this, where we break down complex systems without the hype and without the buzzwords. I'm your host, Oluwole Majiyagbe, and see you in the next one.